These are the notes on probability tree diagrams and reversing the conditioning. Let's look at example 1. In a perfect world, when a person goes to his or her doctor to undergo a test for a particular disease, the doctor would get a definitive answer. The doctor would conduct the test and inform the patient with 100% accuracy that he or she either did or did not have the disease. Unfortunately, we don't live in a perfect world. A medical test administered can be incorrect in two ways. The test can report a positive, the patient has the disease, when in fact the patient does not have the disease. This is called a false positive and is represented by the conditional probability, the probability that the test is positive given no disease. Alternatively, the test can report a negative, the patient does not have the disease, when in fact the patient does have the disease. This is called a false negative. And this is represented by the conditional probability, the probability that the test is negative given that they have the disease. A correct positive is represented by the probability the test is positive given they have the disease. And a correct negative is represented by the probability the test is negative given that they do not have the disease. Suppose that a test run for a particular disease has a false positive occurring with a probability of 0.015 and a false negative occurring with probability 0.003. A patient named David hears that 1% of the particular population to which he belongs has the disease in question, and he goes to get tested for the disease. The doctor calls David back and tells him that he has the disease. David goes into a panic. But should he? What is the probability he actually has the disease? We're answering the conditional probability, the probability he has the disease, given that the test is positive. So to go about doing this, we're going to use tree diagrams to draw a picture and then come up with the different probabilities to find the probability that David has the disease given that the test is positive. So let's go ahead and start our tree diagram. So first we need to start with David's population. In David's population, there's two different probabilities. One, that the people in his population have the disease. And that is 1% of the people. And then do not have the disease. And that is 99% of the people. Then, going off from each one of these, the probability of getting a negative, given that they have the disease, is 0.003, and the probability that it's positive, given that they have the disease, is 0.997. The probability that it's positive given no disease is 0.015. And the probability that it's negative given that there's no disease is 0.985. So what we're going to do is we're going to go through and find all our conditional probabilities. So we're going to have 4 different ones. So I usually draw my tree like this first, and then I go through and find the probability of I have the disease and I get a negative. Okay, so that's going to be our first one. So the probability of disease and negative would be 0.01 times 0.003, and that would be 0.00003. The probability that I have the disease, or David, and it's positive is 0.01 times 0.003, 0.997, which is 0.00997. Then the probability that David does not have the disease and he gets a positive is 0.99 times 0.015, which is 0.01485. And then the probability of no disease and it's negative would be 0.99 times 0.985, which would be 0.97515. So they're asking us, what is the probability that we have the disease given that the test is positive? And that would be the probability of disease and positive test all over the probability of positive. So if I go ahead and I look on here, disease and positive test would be right here. So I have the disease and positive test. So that would be my first number that I would put in. So that would be 0.00997 divided by the test is positive. So the test is positive here and here. So that would be divided by 0.00997 plus 0.01483. And when you put that in your calculator, it'd be 0.4017. So the probability that David has the disease, given that the test was positive, would be about 40%. So should he be in a panic? What is your opinion on that? Please be ready to share that with me when we have class on Thursday or Friday. You could also go ahead and look at number 35 and 37 and try those on your own before class, or you can also wait until class.